Welcome to PC Gaming Tech Summary. As you may know, I'm your host Gamer, and today we look at decreasing our CPU temperatures even further. Yes! So we are going to undervolt the 12700K and see what happens. Well, we have some good results. In fact, here they are. Sit right back, have a cup of coffee, and we'll get into it. Here are the results. Now on the yellow row, we've got stock settings for the 12700K. So that's got no offset for the voltage, core voltage. We rendered a video that's 528 seconds in length at the stock 4.7 gigahertz boost clock and the 3.6 efficiency core boost clock. And we've got a render time of 203 seconds and an average CPU watts of 129 and an average CPU total package temperature of 64. Now, when I uninstalled the Lasso app, the Project Lasso program, I had been using that with a special power package or power setting where it would keep the frequency at the maximum boost clock that was set. So for instance, you'd go in and under these conditions it'd be 4.7 gigahertz all the time. Now, I was having a little bit of a problem with stability with undervolting, and I just thought about that, so I just uninstalled it. Project Lasso, you can basically set it to use certain cores for certain programs, and it was interesting, but I think it gets all a bit complicated when you're doing that. So I'm just uninstalled it, and now the frequency is bouncing around. Okay, if the computer doesn't need the frequency, then it drops it. Okay, so now I undervolted the CPU, okay, by 80 millivolts, which is 0.08 volts, okay? And so it's an adaptive offset. I'll show you that in a moment. Of course, the video length is the same throughout. We've got the same frequency stock settings and very similar rendering time, okay, just within the margin of error. And we've got a reduction of 14.5% in power. In watts, we've dropped from 129 to 112. All right, as well as the temperature has dropped from 64 to 58. Now, when you render a video, it uses between 90 and 100% of the CPU is utilized. So the utilization is above 90%, and it maxes out at around 100% for each of the cores. So it's really using that CPU and stressing it, okay, when you render a video. So that's why the watts are so high, okay? And so we had a -6 degrees C improvement. I found a sweet spot, which is 4.5 gigahertz in the performance cores, the P cores. Okay, so these are large cores with 2 threads each. The efficient cores, the E cores, are small, like laptop type cores, okay, with only 1 thread each. So the CPU has 12 cores and 20 threads. All right, so at this sweet spot, 4.5 gigahertz, the power dropped another 10%. Oh, look at that. Just by dropping it 200 megahertz, 0.2 gigahertz. And so the total savings in power was 23.7%. Now, that's not the entire power usage of your entire PC. It's just the CPU, okay? And we only had a 3.4% reduction in rendering time. So we lost, say, 7 or 8 seconds by dropping the frequency just a touch. Now, if we go the other way and we go to 4.9 gigahertz, rendering time is 197, and the watts shoot up to 151. Oh boy. And the package temperature for the CPU package temperature is the combination of both the P and E cores, okay? That whole environment, the temperature of that whole environment, and it's 70 degrees C, okay? And that is 15.2% increase, okay, in power. And you only gain 3% in time. And you increase the temperature 6 degrees from stock. So the stock is 64 and it went up to 70 on average. Okay, now what if we just go ahead and drop the frequency to 4 gigahertz? So there's a lot of people that have CPUs at around that speed. For instance, my old 7700 4-core boost was 4 gigahertz. Okay, and that's back from 2017. Okay, and there are quite a few people that have AMD CPUs around that frequency. Now, what happens there? Okay, we get a rendering time of 233. Okay, so over stock, that is 30 more seconds, a half a minute. Okay, so that is a 13.8, or you can think of it as 14% increase in time to render the video. And we decrease the temperature from stock from 64 by 15 degrees. Okay, all right. And so, as you can see, only 3 degrees from 4.5 gigahertz. All right, so I find this to be the sweet spot right here at 4.5. So I am not telling you to undervolt your CPU by any means, okay? I'm just showing you what I've done. Anything you do or don't do is at your own risk, okay, as always. I'm just showing you what I've done and the results that I get. Okay, so we've got the Intel Extreme Tuning Utility. Okay, so you get this along with your Intel CPU. Basically, it's a free program. And basically, you can change settings to your CPU if it's a K chip, for instance. And if you crash it, what happens? Okay, computer boosts back up, and it uses default settings. Okay, so that's why I'm not changing the settings in the BIOS. I'm just doing it using this program, and I have it set so yeah, it just diverts back to the stock frequency from the Asus 490 Z490 P for Prime, I believe. Wi-Fi DDR4 D4 motherboard. Okay, and so this way there's not such a drama messing around with the BIOS and the motherboard and all that. So I find this just a bit better. There is one disadvantage. Okay, if you have trouble with your Windows 11, like being able to launch programs, see your taskbar launch from there, what I do is I just do Control-Alt-Delete to go into Task Manager, and for some reason that just fixes it, and I can do everything and launch all the programs. So if we take a look at Task Manager, okay? With the extreme tuning utility from Intel, it's using 2 gigabytes of my memory, okay? I've got a total of 32 gigabytes of memory, so if you only have 16 and you're gaming, and you got to keep an eye on that. So anyone building a new computer, I would advise having over 16 gigabytes of RAM, okay? It's just very nice, especially if you're going to render videos. You really need more than 16, okay? You just want everything to run smoothly and not be stuttering and all that kind of stuff. Okay, especially with the DDR4 memories being so cheap compared to DDR5. Now, DDR5 is dropping in price, so just have a look. You might be able to get a deal that you like using DDR5. Of course, if you're going to do that, your motherboard needs to be able to handle DDR5, so don't forget that. All right, so it's using 2 gigabytes of my 32 gigabytes of RAM. Hey, I got 30 gigabytes left, no worries. All right, now we are going back and have a look, okay? So over here is just the settings that it's running at the moment, okay? I've got no offset there. All right, so if you scroll down here, you can see how the cores are set. So if it's only computer's only going to use 1 performance core, it can go up to 50 X, or that's 5 gigahertz basically, okay? So if you're using all 8 of the P cores down here, then the max boost is set to 4.7 gigahertz or 4,700 megahertz. Okay, now the efficient core is set at 3.6 if you're running the 4 efficient cores, okay? And you come down here, and this is where you can set the maximum frequency for each of your cores. So with my CPU, the 12700K from Intel, it had designated my 2 best cores as Core 2 and Core 3. And now those are 2 of my very worst cores, probably because of the 240R AIO, you know, not doing its job as it's designed, and yeah, not performing, and basically clogging up and not working properly, and probably damaged my cores, is I'm guessing, okay, allegedly, okay. So my best cores now are core number 6 and core number 1 and 0 and 1. So I've got 3 good cores, 0, 1, and 6. So I've just changed that so that if it's going to use 5 gigahertz, you don't need to use those cores, okay? So basically what I'm doing, again, this is what I'm doing, I'm not saying you should do this, is I would reduce, so negative 0.08 volts, which is 80 millivolts, okay? So if I do that, it's showing up here as yellow as the proposed change, okay? I would click apply and continue if I accept the risk, okay? And so you can see over here 0.08. All right. Okay, so I use the 80 millivolts. My CPU's not the best silicon that you know. Each CPU is different, and at around 0.1 volt or 0.09 volts, I've had one crash after playing for hours using Cinebench, running Cinebench, and playing games and stuff. So I dropped it down to 80 millivolts, 0.08 volts, and I haven't had a crash running that offset. So that one is working for me. Okay, so if I want to load up a profile, click on Profiles, and so this one here is 4.9 gigahertz, and with the 80 millivolt offset negative. Okay, negative offset, negative 0.08 volts. Okay, so how do I load that? Well, I select it to start with, and then I come up, scroll up to the top, and I show those values. Now, if I want to have a look at those values, I would click Advanced Tuning, and then I can come down and see all the values here. Okay, and so these are the proposed changes. So I want it to go to 4.9 gigahertz on all cores. Okay, and I've got it set here at a 3.8 gigahertz for the E-core, so there's a slight overclock there for that one. And then individual core, I set the individual core maximums. Okay, so these 2, 3, and 7 are my worst cores. So I actually have them only boosting to 4.8 gigahertz. And then I've got 1, 2, 3, 4, 5 cores that can boost to 4.9 gigahertz. Because the maximum for 8 active cores is 4.9 gigahertz. And then here is the individual performance core ratio multiplier. Okay, so this one's been working for me, so I just click Apply. Now you see the little blue spinning around. Well, if that freezes, that means it's locking up, a crash. Wait 5, 10, 15 seconds, and your computer will probably be reboot. Sometimes it doesn't, it's just locked and frozen, and then you need to, then what I do is I click the reset button on my computer. Well, if you'd like to see some more videos like this and on a wide variety of technology subjects, all you have to do is subscribe and you'll get notified when those videos are ready. And I always welcome suggestions, and thanks for your comments. In fact, I've got a very special thank you. We have 50,000 views of our videos here at PC Gaming Tech Summary, and I want to thank you for watching, and I want to thank the people that have commented and also subscribed. I want to thank Rick Sanchez for commenting, and I want to thank Prez Lee Tagur. All right. And Rough Play again, thank you. Nick Alger, thank you very much. Otaku, yes, thank you for commenting. And also, we have Andrew Barrows, thank you for commenting, I appreciate it. Taran, thank you very much. Again, Press Lee Tagur, fantastic. Another comment from you. And Alexandre Pinto, all right, thank you. And Sean B.Z. and Ashley Gillette, all right. And we've got Elias Sanchez, Ricky Smith, Skinny Cat. And again, thanks for joining us here on PC Gaming Tech Summary. And don't forget, you'll be seeing me in the next video.